Now I'm going to ask our next panelists to come up and join me here on the stage. It's my privilege to introduce our morning plenary on a topic that I find fascinating, decarbonization, electrification, and the next generation grid. The discussion is going to be moderated by James Glaive, who is the principal at Glaive Communications. James provides strategic and hands-on communications support to companies, industry associations, organizations, and governments who are working to grow the low-carbon economy. He's a passionate advocate for decarbonization. He's co-founder and former communications director for Clean Energy Canada, and a senior fellow and lead communications advisor for Future 500 in San Francisco. He is currently working on the editorial team producing the REN 21 Global Renewables Status Report, among other projects. I'm going to ask James to further introduce the other panelists, who include Chris Bataille, adjunct professor, Simon Fraser University; John Rylett, who most of you will know, former board member of CanSIA and a director of energy solutions at ENMAX; Matthew Williams, CTO and founder, Faraday Grid and Emergent; and Ann Smart, vice president, public policy at ChargePoint. Thank you, everyone, and please join me in welcoming our panel.
Good morning, and thank you for that very kind introduction. I just want to begin by acknowledging that we're holding this event on the traditional territories of the people of the Treaty 7 region of southern Alberta, and that Calgary is also home to the Métis Nation of Alberta in Region 3. And so thank you and welcome again. The introduction really covered well what we're going to be talking about this morning. I'm looking forward to a really cool panel discussion with a lot of really interesting perspectives and very smart brains on my right here. So just very quickly, you heard the introduction about me. We're going to get right into it, and we're going to be doing just a conversation here, and then we're going to be going to allow for about 15 or 20 minutes of Q&A with the audience. So without any further ado, I'd like my panelists to each introduce themselves, take about 90 seconds to kind of give you a snapshot of where they're coming from, and then we could dive in. Starting with Chris.
Okay, I think everybody can hear me. I've been doing this for a little over 20 years at this point. I had about 18 years of nitty-gritty energy consulting here in Canada. And then about 6 years ago, I was lucky enough to get involved with something called the Deep Decarbonization Pathways Project, where my group was asked to look at what it would take to get to minus 80% by 2050, which was required for a 50% chance of 2C at that time, heading into the Paris Agreement. It was a bit of a stretch. There was a lot of hair pulled and sweaty nights and what have you, but we mapped something out, and it was deeper than we'd done for any other previous analysis for the National Roundtable, for the federal government, what have you. And since that time, I've gone on to working for the global organization that organized this, and I do the same kind of studies in developing and transition countries.
Cool.
So my name's Ann. I'm with ChargePoint. I've been at ChargePoint now for 5 years. Prior to joining ChargePoint, I was the executive director of the Alliance for Solar Choice, which was an advocacy group created by SolarCity and Sunrun in the U.S. to work on net metering battles. I know what you all do, and I appreciate it. I now work in electric vehicles. ChargePoint makes electric vehicle charging stations. We're the largest network in the world with more than 64,000 charging ports and about 150 here in Alberta. We make charging stations for everything from home charging up to bus and truck and eventually flying cars with Uber Elevate. Thanks.
Morning, everyone. This is my first time in Canada. Very happy to be here. It does feel a little bit full circle for me. Our first investor was AMP Energy, a local Canadian solar developer. So it's really great to finally get to come here and visit Canada. So I'm a mechatronics engineer by background. I'm Australian, and Australia is quite similar to Canada. We have a large space, a relatively small spread out population, and a really good spot for renewables. So about 10 years ago, I started to see that we were going to have an increase in renewables with the push to decarbonise, but there was no real technical solution on the horizon that was going to enable us to achieve the levels of decarbonisation that we wanted whilst maintaining a reliable and affordable electricity system. So that was the point that Faraday Grid started. And so we are developing a new platform for energy. So we use the same poles and wires, but we're able to transform the grid into a system that can have much more renewable energy whilst maintaining its resilience and reliability, and bring down the cost of energy for the consumer, for the system operator, and for everyone involved in the energy system, including the solar developers.
And I guess I'm last. Good morning, everyone. I'm John Rylett. I work for ENMAX Corporation. For those of you local, you probably know who we are. For those of you who don't know us, we are effectively a vertically integrated utility company. We have about 1,600 megawatts of generation here in Alberta that spans everything from natural gas to utility-scale wind to distributed resources. All of this discussion about decarbonization and the future in carbon affects us across our whole business. We're also the largest retailer of electricity here in the province. So as we move forward, we have changes that will impact all of our business, whether it's our generation, our distribution utility here in Calgary, our customers on the end. We see opportunity, but we also see challenges in terms of what are our customers going to want and need, what is the policy framework that is going to move us ahead in this space, and of course, how do we get this stuff to work and talk to each other if we're looking at our distribution utility and keeping up the reliability standards, but also paving the way for what we're going to see as or what we believe to be an increased deployment of distributed assets, distributed renewables, EVs, and that whole mix coming together if we're going to hit this sort of decarbonization, low-carbon future.
Okay, well, thanks, everybody. So then I want to get us started by queuing off of Chris, what you said, your work on the deep decarbonization pathways. You set 2050 as the target year. So let's say we are in 2050. Canada has overwhelmingly decarbonized its energy system and its economy. What does life look like, out there on the landscape? Is everybody driving an EV? Is nobody driving? Paint the picture for me. And why don't we start with John, actually, since you're sort of closest to the ground.
Sure. I mean, in terms of vision for that, like if we get to that aspirational goal, to be honest, I think it looks pretty good. I think while that's a challenge, I think it is in line with other challenges that we have met in historical context. I think you will see much more electrification across industry and transportation and places like that. I think we will see perhaps people driving less. I think we will see less maybe single car ownership. There'll be more car share and those sorts of things. And ultimately, I think in the underpinning of it all, we're going to see much more renewable generation, probably some technology that we haven't even really worked out yet, whether that's carbon capture or something like that will contribute, and storage. The ability to store energy, to turn electricity into something that mimics more like other commodities we know today. We can store oil, we can store wheat, we can do those sorts of things. If we can get to that, it opens up I think a much different future for our energy systems and networks, and of course our users. So I'll start with that.
Next, who else wants to take that one on?
Adding on to that, I think that we'd all probably have similar versions of the future. Certainly at a grid level, there's going to be a lot more distributed, large-scale renewables. Energy storage in some way, shape or form is going to have to be part of it. But down at a consumer level, we're already starting to see this future where you have your PVs on your roof and your battery in your garage, your electric vehicle. They're wanting to sell in and out of the grid. And that future from a technology perspective is not too far away. How we integrate it all together is going to be the challenge. And I think building on what John just said, one of the things that I think we need to be mindful of is we're talking about something that's 30 years away. Technology is only continuing to advance quicker and quicker. So undoubtedly there will be a mix of ideas and innovations that we haven't even thought of yet that form part of this future.
Right. I mean, if you look at the acceleration of smartphone technology and how that's completely reshaping mobility and everything, it's just it's pretty tricky to try and expect where it's going to go.
Exactly. So one of my personal fears is that we make decisions now either in policy or technology, which then prohibit new technologies from coming in and doing an even better job.
Okay. We'll want to get to your company's solution to that challenge in a moment, but I want to hear from both of you. So, Chris, do you want to go first?
Yeah, sure.
Who's up?
Sure. So ChargePoint's been around for 10 years, and really the electric vehicle industry that we know today has only been around for about 8 years. So you can just imagine where the vehicle industry itself has evolved in just this last decade. Now we're getting away from just light-duty vehicles. We're into longer ranges on both light-duty as well as buses and trucks. And so by 2050, I'd expect like fully electric across both our light-duty as well as medium and heavy-duty space, as well as a shift towards autonomous, particularly in the trucking industry. We're seeing more innovation there. And as a result of that, what my company calls fleetification, we expect that cities and local power sources will become even more important. Planning around local transportation and energy needs to make sure that this autonomous ride-sharing fleetification world is powered and sustainable, I think is going to be really important by that time.
Cool.
I'd just like to throw a little bit of a long-run perspective into this. Since the Industrial Revolution, like Catherine was talking about earlier, we've gone through a progression of more and more useful energy forms and more compact that are more useful for doing specifically the work we want to do at a given point in time. We started with coal, then we moved on to crude oil, then we moved on to gas. It was a fairly natural progression heading to electricity, and had civilian nuclear power worked out as we hoped in the 50s, we might not be having this conversation here today, but that didn't happen. So there is a natural progression towards using more and more electricity in the economy because it allows you to do exactly the work you want to do. It allows a systemic efficiency that doesn't really occur with thermal fuels. Now, what's happening is that natural progression is being accelerated by climate change pressures, being accelerated by air pollution pressures, what have you. So it's a natural progression, but the question is, can we do it fast enough to meet our climate change requirements?
Okay, that sounds awesome. So then I want to just sort of continue the theme of that last question, and along the lines of when we talk about today's grid infrastructure, self-generation, distributed generation, and when we talk about the grids that we work with today, there's a lot of talk around sort of how do we adapt and make it work and sort of solve the issues of integrating very large portions of renewables onto a system that was set up for a very different model. So what if we could take a big magic eraser and just basically start again? What would the grid look like today? I mean, maybe we still have the wires that we have out there, but what if we, erased our current, infrastructure in terms of distribution and so forth, and what would the ideal grid setup look like? John.
Ooh. No pressure on that one.
No.
It's interesting. I might reframe that a little bit because I'm not sure if we can, if we could throw it all away and start over, clean slate, that might be a good thing, but very difficult. And I think one of the biggest challenges we're going to have is actually how do we transition our grid? We know in certain instances, you get the leapfrog effect. In Catherine's thing, she talked about how silly it would be to go to a developing nation and say, here, we're going to get you a party line. It's a copper wire. There's somebody sitting in a switchboard pulling out wires and doing things. And are you kidding? Give me a cell phone. I'll put a cell tower over there. The whole town now has communication, right? Perhaps if you were starting with a clean slate, you could do that. But the value of being interconnected is enormous. Even if you are a new prosumer, even if you're generating energy on your roof and you have your electric vehicle and maybe some battery storage and things, being connected is still very, very valuable. So I think the big challenge here, and we look at this as as basically a generator and a provider of distributed energy technologies, as well as a distribution utility, is okay, what do we bet on and how much? Mentioned it a minute ago, again, one of our fears is a lot of electricity infrastructure is around for a very long time. You make decisions that you intend to last for 30 years and beyond, but technology moves very quickly. So how do we avoid massive sunk cost or stranded assets in one respect? How do we make it flexible to handle what could be coming next, and how do we do that? And then what is the core challenge we're looking at? I can give you one quick example. Our distribution utility did a study with Dunsky Consulting. They tried to look ahead, and they isolated around electric vehicles in our Calgary grid system, as well as distributed renewables, which is effectively solar, because that's what fits in cities. And a couple of interesting things came out of it, because it started with the, oh no, are we going to be in trouble here? If everybody buys an EV, or I shouldn't say everybody, if we get EV penetration along a pathway that we think is going to happen, do we have a massive problem? And the answer that came back was, well, actually, no. No, the infrastructure as it is today can handle it. And in fact, if you lumped in and managed or looked at the expected adoption of distributed solar and the expected adoption of EVs on various different pathways, we actually projected a net decrease in total consumption. The challenge is that the timing doesn't line up. A lot of solar during the day, obviously, and more EV charging at night. So then it becomes, okay, well, it's not an overall capacity thing that we're looking at in that particular context. It's more of a, how do we handle the timing? Right? And that begs a different solution than if we thought, holy cow, peak load's going to go up by 2.5 times because of this shift. Anyway, so it's all of these things that trying to get a handle on and trying to figure out, how do we, I think, maintain some flexibility while keeping that reliability? Because that's the other thing. I was thinking about this last night. How can I draw parallels? And who remembers Windows ME? Anybody try that on a computer? Were you happy? Did it work? No. You can't try Windows ME equivalent in the electricity space because it's too important. And so we have that extra pressure on ourselves to get there. So,
Matthew, I'm going to let you take the...
Yeah, I think from just touching on the EVs, I mean, electricity grids are in some ways the same world over. Physics is physics everywhere. But then at the same time, it's completely dependent on your loads and your generation, the topology of the grid. So I was speaking with a utility a couple of months ago, and their study had shown they could only support 4 EVs per street, which is obviously a huge challenge. And there was an article in Melbourne, Australia, a few weeks ago that was saying they're already starting to see in areas with high penetration of Teslas that they were starting to see issues in their instantaneous drawing things. So there are some challenges, but when we start looking at, the grid of the future and if we could wipe the slate clean, agreeing with John, there's the massive investment in that means that it's just not possible. And one of the challenges, I think, is if we take the traditional kind of design by precedence engineering approach of looking at the grid and saying, what can we add into the system to try and mitigate these issues and help us extend the life of this asset? I think that's the wrong engineering approach. So the way I look at it is, what does the energy system need to be in the future in order for us to achieve our goals? And let's work backwards from that to see how we can actually achieve it. So, I won't go into too much detail about my particular solution for how to achieve that, but I think the approach of just adding more and more technology onto the grid is potentially not the right way to go.
Okay, technology, that's the key, is innovation and driving forward and trying to solve those issues of integration and so forth. I want to talk about policy, shift gears for a second here, Chris, and throw to you. In terms of the research that you've done on decarbonization, the pathways, massive increase in renewables, demand reductions that come with that and so forth. What do you see as the most important policy solutions, both provincially and federally, to really accelerate electrification, clean up grids? There's a whole box of tools out there that governments can use. What favorites, or where are you seeing great success? Perhaps in Alberta.
There's a very large dispatch order there. It's all sectoral to a certain extent, right? Like there are key sectors that we know for new builds. Electrification is really the smart way to go in terms of, as soon as we can, your new build on your light transport, your light return to base freight, new residences, new buildings, what have you, new light manufacturing. And that's the big thing that's just over the mountain, is that once we start getting really started on this project, there's going to be a massive amount of industrial electrification. And we're talking gobs and gobs of megawatt hours and gigawatt hours when you get to that point. And a lot of that, so for the...
You're going to get everybody here really excited.
but the consumer-orientated stuff, I'd say we stick with things like CAFE standards, performance regulations run by the government, and they're graduated out through time such that early as possible. The only thing you can buy is a BEV or a FEV, and in new builds and houses, they're highly efficient with heat pumps, what have you. We're going to have trouble with the older stock. It's going to be very difficult. You can't retrofit everything with heat pumps, what have you. You're going to need renewable natural gas. You're going to need hydrogen just to dump on it, help reduce the GHG intensity of that grid, which gets into the other part of my research, which is what does electrification need as a supplement to really work on a massive scale? When we start doubling and tripling the amount of electricity that's used, and the fact that, there's a slide, the Shell Sky scenario? If you look off to the right there, what you're seeing is Shell, an oil company's projection for a 2C compliant scenario if sufficient policy is in place. And if you look at the exponential thing on the right there, that's their projection for solar going out past 2040. Okay, so go ahead.
So why is that crossover point happening there?
Cost. It's just simple cost. Their projection, basically, you go out with the solar is lovely in the fact that with manufacturing efficiencies of scale, it's not inconceivable to think of 0.5 cent to 2 cents per kilowatt hour solar. The problem is it's predictable, but it shuts off at night. Right? So how do you build a large system that's consuming ever and ever amounts of the solar that's sloshing around in the grid? And you're going to need other solutions. You're going to need demand response in industry. You're probably going to need transformation into hydrogen. Now, hydrogen is highly explosive and corrosive. You don't really want to keep it around. So you're probably going to catalyze it up into ammonia, perhaps into methane if you've got a net zero carbon source, what have you. But this gets into a whole other class of difficulty, a class of policies and difficulty and what have you. In the near term, for the consumer stuff, just stick with the regs. In the longer term, we need some intensive planning between folks like the AESO, the industrial operators, and what have you, to make sure that the right equipment is in place to suck up that. We don't want to curtail this. We want to use it. And how do we use it in the smartest way? And that's going to require some long-term planning.
John, is ENMAX, to what extent are you looking into utility-scale solar so that we can make the best use of the resource? The solar resource in Alberta is, of course, outstanding. As you look way down the line, you don't have any utility-scale solar assets right now, do you? Or am I?
We don't have any utility-scale assets now, and that's largely because we've been focused on the Alberta market. And right now, functioning, there's one, which received significant, government funding. We do have 3 wind farms because there was a regime and a policy structure, et cetera, market that made sense for that. We look at all types, well, not coal. We look at all types of generation as future options. A lot of it will come down to what is the policy, what is the market structure, do we believe it, and how stable does it seem to be, right? One of the challenges you have, again, solar is no different than most electrical infrastructure. It's going to be around a long time. And you want to know with some certainty that if you build assets, that they will be, valuable through that time period. So whether it's solar or wind or something else, could it be solar with storage? What is the cost curve on that? What's going to compete against it? There's a game going on, basically. You're always trying to play with that and figure out, what's going to be, a good investment to move.
We're starting to see some power calls in the States of combined storage and solar, combined wind, so that's like part of the call. Do you see that eventually coming to Canada, that kind of level?
Yeah, definitely. The ability to store renewable energy, it's the game changer. If we keep continuing on the cost curves that we've seen, where we've seen the price of battery storage come down in double-digit percentages each year, year over year over year, I think we're seeing combined pricing in the U.S. that's in the neighborhood of 4 cents a kilowatt hour. That's solar with storage. We're not there yet in Canada. We're still a ways from that. That is a game changer. That offers you much more flexibility. The question is, when will we get there, and do we have the right sort of market and policy regime that facilitates it?
And it's over to you now, because electric vehicles are, of course, storage. Mobile storage fleets are one giant parking lot full of batteries. So I'm just curious, that's still a ways out before we're there yet. But I'm just wondering sort of like what the lay of the land looks like from your perspective with electrification. The federal government has set a fuel vehicle phase-out date of 2040. No new gas or diesel-powered cars on sale in Canada by then. There's a national incentive just launched. So far, we've seen most activity in BC and Ontario and Quebec, of course. But how do you see that changing? Is the federal incentive going to help?
Yeah. So ChargePoint's business model is that we sell charging stations that are independently owned and operated, and as a result, we've been able to actually sell a charging station in every province in Canada. We work with local installers. Shout out to Virtuous Energy if they're here. They're our solar and EV partner here in Alberta. But our business model enables us to sell a little ahead of where the policy might be. It's often difficult, though, as you can imagine, to sell a charging station if there isn't actually an EV to use it, to convince a business to make that investment. So having this incentive nationally for EVs will really help bring more vehicles, hopefully, to local dealerships, which in turn will support the market. And I'm going to cough, so you should turn off the mic.
Take your time. Anybody else? Do you need a minute, or do you want to? Okay. Bit of laryngitis.
I made it through my panel yesterday, but the good news is we're seeing policy everywhere. The first step is to make sure that we get the ability to charge per kilowatt hour. Sorry, I have no voice. So here in Alberta, there is a grid mod docket open. We're excited to see where that goes. And BC, as you mentioned in your notes, not verbally, just passed a rule enabling our customers to charge per kilowatt hour. But we still need to work out some issues with Measurement Canada on metering, make sure that as we roll out smarter grids that the smart meters can actually talk to the stations, and then work with utilities to create policy to create rates that support charging. I'll leave it at that for now.
Okay, that sounds good. If that wasn't clear, British Columbia has just gave the green light to the grid regulator that it's all right for private companies to resell electricity for charging, and also for landlords and condo stratas, I think. So that's a key barrier that is going to open up the market there, and hopefully that policy spreads wide and far. So then I'm curious, John, I want to talk briefly about the other sector in the States where Anne is from. There's huge interest in corporate direct purchases of virtual PPAs, and IKEA in Canada certainly bought a couple of wind farms. There's less activity there. I'm just wondering what you see the future looking like there for, say, a company like Walmart Canada or another large company with a lot of roof space that decides it want to meet more of its internal sustainability goals with direct generation. I guess Alberta is very well set up for that, given the deregulated market.
Yeah, I mean, if we're talking about sort of like the corporate virtual PPA, Alberta does have the best market in Canada for that, because we actually have an open market. If you want to build a facility and interconnect, you can do that, as long as you're happy with your financial projections, go ahead, versus, other markets where it's, say, a Crown Corp, and they get to decide what's built on what schedule and why and when. So you have that opportunity. we lag the states a bit for a number of reasons. Price being one. We're slightly more expensive here, and we've had traditionally cheap traditional electrons, if you will. We're seeing different price pressures in the U.S. The U.S. has also benefited from things like investment tax credits and things like that allow sort of tax equity flips and stuff move along. So there are some differences there. However, I think it is a market you will see grow in Canada as long as there is a signal and a desire to decarbonize, and if that's a pathway. And that's the big thing. I know in our experience, we have customers who are interested in this. Shout out to the city of Calgary, who went 100% green, I think more than 10 years ago now, with an asset-backed agreement off of wind at the time. We've seen some government procurements pushing in that direction, if not 100%, but at the Alberta infrastructure procurement that occurred fairly recently. The real question is going to be, again, though, the policy and the market driver for it. If it's a voluntary market, it's priced very differently. The desire from the customer can be quite different than if it's a compliance market, i.e. like our previous CCIR regulation or specified gas and minerals regulation or the potential new tier program that we heard about yesterday. Ultimately, I think we will see more of it. It will depend, though, on what the structure and the drivers for it are. And right now, I'd say we're kind of waiting a little bit to see how that plays out, and to see how those kinds of relationships can function in our markets going forward.
Gotcha. Okay. So then I'm just curious, sort of just an open question for the panel. Give me a sense of how you talked about the industrial sector being one of the most interesting ones for electrification. To what extent, are cities and the role of local governments going to be involved, or going to be key drivers of that? John, obviously, MX is a city-owned utility. I'm thinking more of the spread we're seeing in climate emergency declarations that many cities, another one yesterday in Nanaimo, St. John, New Brunswick before that. I'm just curious sort of about the role of local governments in opening up and accelerating electrification using the tools that they have. Anne, how's your voice feeling?
I think it's working. You turn the mic back on.
Does anybody have a Halls in the audience now?
Sorry, I have.
You sound great.
So for us, we see cities as really key. One of the things important for electrification is making sure that all new construction and retrofits are including enough panel capacity to support future charging stations. So EV-ready building codes has been something we've seen a lot of cities move forward with, particularly in BC. And we think it's a great way to start that conversation. Even just the minimum of making sure that there's capacity at the point of new construction can reduce the cost of installing a charging station later by more than half, because obviously you got to rip up a lot of parking lot to put that in. So we see that as key. And then seeing a shift for public agencies and cities towards electrifying their fleet vehicles, particularly municipal buses, and creating the support needed for the energy at that site. So we've seen some of our first vehicle-to-grid projects come from cities transitioning their municipal bus fleets to electric. We have a couple pilots in California. And we're seeing a broader shift towards at least the non-emergency vehicles provided by cities on electric. So we see them as a first adopter, and that can help guide more electrification across the rest of the city.
Matthew, I want to hear from you next. I want to hear about the Faraday technology and how it would help accelerate electrification and by opening up the marketplaces more freely. Can you just give us a sort of a thumbnail picture of the solution, and would it work in a context like NMAX, a utility owned by a city?
Yeah, so first up, just speaking on cities more broadly, obviously we know they are growing. That's generally a good thing for human welfare. One of the key things of having such a large amount of energy usage in a small location, especially when generation is not typically in that location, is it becomes a real threat to the overall grid stability. And ultimately, that's driving up the cost. In somewhere like New York, down in the US, 80% of the price that they pay for electricity in New York has nothing to do with the cost of generation. 80% is the cost of getting it to the consumer. Globally, that's closer to 50%, but when you start looking at cities and if they're going to grow, we're going to have huge costs associated with just managing, whether it's managing the voltage and frequency in there, managing capacity constraints. So whilst things like solar, when we were touching on the cost before, solar in my head should ultimately be cheaper than something like coal, because coal, you've got a consumable. Your first unit of energy costs X based on asset value and your inputs, and the last cost X still. But when you look at wind or solar, the last unit of energy should effectively be free. So the more we can get out of these assets, the lower the price of energy should be overall. So you then start to look at how can the grid better support these to make them more reliable in terms of the efficiency of the grid, but then also bring the cost down. So for Faraday Grid, we're working with a number of utilities globally, because our technology is designed more to be a new platform for electricity rather than a new widget that you just put in and it helps resolve some local issues. So it's designed that you can literally pull out one transformer from the existing electricity grid and put in one Faraday exchanger, and then in its local area it starts to balance voltage, power factor, remove all of the harmonics. But then as you put multiple devices within a single grid, they start to coordinate and collaborate using autonomous decentralized control, which is a really fancy term, but basically it just means there's no master controller trying to monitor and control one of the most complex assets on the planet from a central point. Putting in just the infrastructure to do that, and then the cyber threat and all of these other aspects mean that that's potentially not the right way to go. The entire internet works using this autonomous decentralized control, and Faraday technology is able to bring that same approach to the electricity system.
Any other panelists want to ask Matthew about any aspect of that? I'm curious, John, if there's a system that would potentially work in this market, or or what your approach would be to evaluate technology.
I mean, it is the multi-million-dollar question. At some point, we are going to need something like this, right? To manage this better, to control it better, to understand it better. We don't have it today. We will need that. Where we have questions, though, of course, is like, well, is it something like that platform? Is the Faraday platform something you commit to? What does our regulator think about it? Would they let us do that? To just dig into the weeds in the Alberta context a little bit, we have separated the energy from the delivery service from a regulated perspective, which means that if you have devices that in theory could do both things, there becomes the bun fight over, well, is it rate-based for the distribution utility, or is it participating in the wholesale energy market? Where does the line cross? Who gets to own it? Who gets to decide what it does? There's a number of things like that need to be accounted for. Again, it's not insurmountable. It's just these are the things you have to look at. And then, of course, there's the question of, is it a system like that, or do you end up getting customers and that prosumer concept going, hey, I'm just going to take care of my stuff behind my meter. You tell me what I'm allowed to do. Keep it simple, and I'll have my solar, my battery, my EV, something else, and I'll just stay within the boundaries, more the distributed model. And I can see that as a potential player in the future as well. Really, like anything else, is it one or the other? Is it both? When and how fast? And of course, what is the regulator going to say about it and going to let you do? And can you test it? And can you test it quickly? All those things come together. So you talk about an interesting time if you're into this world. If you're got that kind of pointy hat on and you really get into this stuff. Like, now is the best time to be here because it's been boring for the last 50 years. Now is when it's happening, and it's going to be happening over the next 10 and 20 years. Anybody who has the crystal ball, please come talk to us because we'd love to know. It would help.
Awesome. I know Chris wants to speak to this. Just before he does, though, we're going to go to questions next. So there's 2 microphones, I believe. Yep. So please have questions ready. There's a lot of talent and insight up here that you could take advantage of. So, but go ahead, Chris.
Yeah, I was just going to say what the gentleman from Faraday was saying. Sorry,
Matthew.
Yeah, it speaks to an essential problem that anybody who thinks about electricity supply has to think about. Is you're solving for 3 problems. There's the energy problem, solving the bulk supply. There's the capacity problem. You know, is it the right amount at the right time? And then there's the ancillary services. Is there a stable voltage and frequency supplied? Now, those 3 questions have to be solved at all levels in the grid. They have to, if you think of your own house as a microgrid, you have to solve for those 3 there. If you think of your neighborhood, you have to solve for those 3 there. If you think of the entire AESO, you have to solve for those. And to a certain extent, the world we're heading into, like, we have a nice, well built out copper transmission network built, but the question is, can we use the new technologies coming online in terms of big data and AI and perhaps services like yours, and able to solve for all those at once with the it's not something that humans can do. It's not going to happen at any speed that we can handle, but it's anticipating at any given point in time where loads are likely to come from, where supply is likely to come from, and balancing it all such that it's in a harmonious whole, including massive megawatts and gigawatts of industrial coming on at the same time. So.
I'm going to go to questions now. I can't quite see it's bright. Is there anybody at the mics? Does anybody have a question? Okay. Well, while you're thinking of your question, wait, I think we might have a taker. Yes, hello, sir. Oh, and a preamble. Please, let's keep this to questions rather than if you're beginning your statement with this is more of a statement of a question, I'm going to shut you down. So let's keep it focused on questions, and please keep your questions brief so that we can accommodate as many as possible. Go ahead, sir. Can you introduce yourself briefly?
Sure. It's Paul Lukanen, Customized Energy Solutions. We're an energy storage consultant. I appreciate the discussion about scale, having looked at barriers to renewables and penetration for a long time. These are the right questions, I think, to be asked. So I'll try to keep it to maybe just one. And that, as far as managing the peak demand on a grid system for the wholesale operator, what do you see as the role that storage can play, perhaps in the context of replacing peakers, nat gas peakers, but just in general, to keep away even for now of managing on a distribution level and having some type of settlement agency on a distribution scale, which I think is an important one as well, just to keep it to, managing peak demand and surplus renewables. How do you see that playing out perhaps in Alberta or on a larger scale?
I can...
Free for all. Who would like to take it?
Okay, I can start. I think it'll play a large role going forward. To your specific example, we're actually installing a battery at one of our peaking facilities. It's our first step into this space. The idea is we can make that peaking facility more flexible and more useful and lower carbon. So I think we're going to see more. The pace of it, I think, is the question. And of course, the where. Where storage could be most effective, depending on what you want to do with it. Is it simply peak energy? Is it transmission constraint? Is it demand constraint? All of those things might dictate the size and the location. Personally, I'm quite bullish on it. I think this is going to be one of the biggest influencers going forward in our grid. The pace of it and the schedule, et cetera, that's going to be the big unknown, I think, at the moment.
I think from a storage perspective, I mean, it's not new news, but it's always going to come down to the cost benefit. And I think batteries are very well suited to the problem of intermittence, time shifting the energy, but at the moment are less valuable in the volatility within the system, these ancillary services, which is a huge cost. In the UK, they spent over £1 billion just maintaining system frequency, and ultimately that's paid for by the consumer. So Faraday technology is able to be coupled with batteries to make them more efficient. We can actually turn batteries into effectively a synchronous generation source, which then has add-on benefits for both the batteries, but then for the grid as well.
Okay, very cool. Gentleman on my left. Hello.
Hey, I'm Liam Hildebrand from Iron and Earth. There is a growing movement towards pushing for net zero by 2050 around the world, obviously. In the US, we've seen the push for the Green New Deal. In Canada, there's a new campaign growing in anticipation of the federal election, pushing for a Green New Deal for Canada. Looks like one of the two policy frameworks that is going to be a part of that is pushing for slashing emissions in half by 2030. Now, do you think that's a realistic goal to be pushing for, a policy framework that would support that as part of the upcoming federal election? Or is that just an unrealistic goal? Should we be pushing, or should that movement be pushing for something else?
Sorry, just to clarify, the goal that you mentioned, was that for demand side reductions, or I didn't quite catch that? I'm not sure.
Cutting emissions in half across Canada by 2030.
Chris, I think you're tailor-made for that one.
I think if a policy is going to survive, you've got to be careful not to threaten the existing stakeholders and unamortized capital. Right? Now that means different things in different sectors. In the industrial sector, that can be an asset that lasts 20, 30 years, but in housing, transport, what have you, those horizons shorten. I think realistically speaking, okay, so we have to go to zero. It's not even a question, and it has to be somewhere, you know, if we want 1.5 to 2C, it's got to be somewhere between 2050 and 2075. But that means everything has to get there. I would suggest that effectively, all the new, what we're working towards, you let out, okay, so you retrofit and make efficient, you run as efficiently as possible, you retrofit you can, but what you have, but what we're all shooting for is that all the new stock is zero as soon as possible. That's basically the algorithm for all the sectors. I don't know if that's helpful to you.
And solar will play a big role in that.
Yes.
Net zero homes, you know, if you're building to that standard, you're generating your own electricity, you're generating on site, right?
Yeah, and basically electrification is the sort of easy answer for most sectors. It's not the answer for all sectors, and you have to think of it too as it's electrification plus another layer of things that build upon the electrification. So somebody was asking about storage. When we start, say we get into that shell world where solar is huge, we need some way of, we need some sort of massive nighttime. We can really bring down the demand at night, but we need some massive nighttime storage that may be provided by fuel cells and hydrogen. So during the day, you're making hydrogen, you run it back to the with a fuel cell, and you run it back at nighttime.
Cool. Awesome. Okay. Next, gentleman on this side. Thank you.
Just a quick question for...
Don't forget to introduce yourself.
Bruce Payson, Independent. A question for the ChargePoint rep. How do you see your relationship with Tesla? Are they a competitor or a partner? Because they can charge at their Tesla turbocharging stations for free. So I'm just wondering how you view that relationship.
Good question.
Yeah, good question. So both. So Tesla's, for people not familiar, Tesla themselves have a proprietary connector. So a Tesla supercharger can only charge a Tesla vehicle. But Teslas can use the standard connectors that are on our stations and all other non-Tesla stations with an adapter. So Tesla drivers are actually number one users of our stations in many places. So we see the Tesla drivers as our customers, in addition to Tesla themselves, you know, creating superchargers and potentially being a competitor in some cases for deploying stations. We also have some partnerships with Tesla, given our need to make sure that every parking lot has the ability to charge a multitude of vehicles. There's often instances where Tesla is co-locating with other charging station companies to make sure that any vehicle can use the stations there. So we see Tesla as really important to the industry evolving, and particularly excited about where they're going with their trucks, and hope to see more of that in the future.
And I've got a follow-up question. Could you give us a sense, what's your installed base right now, or of charge points, not chargers, but individual? How much charge point infrastructure is out there?
We have 64,000 charging points across North America and a little bit in Europe, where we recently expanded. About 5,000 of them here in Canada, about 150 here in Alberta.
Okay, very impressive. Okay, so we're going to have to wrap this up. We've got about 5 more minutes. Did you have a follow-up? Oh, sorry.
Hi, Rod James from Canadian Commercial Corporation. Another question for Anne. As an EV owner, I've come to the conclusion that charging speed is probably just as much of a future enabler as range of electric vehicles. The less time you spend at a level 3 charger, the better. Can you get a sense of what you see the rollout looking like for ChargePoint for level 3 in terms of kilowatt capacities?
Sure. So our current fast charger that's available on the market is 62.5 kilowatts, which, just for timing's sake, can take about 30 minutes still to fully charge most of the vehicles out on the market. We've announced a product that has the ability to ramp up to 400 or 500 kilowatts. So we expect that charging time, depending on the vehicle's capability to receive a higher charge, to get down to 10-15 minutes. Where we need to see more of the evolution, again, is the automakers rolling out cars that can receive that higher battery. We've seen announcements. I think Hyundai announced yesterday that their new Kona for next year will have a higher capacity to take that higher speed. Right now, it's really been the luxury vehicles that are capable of receiving that full 500 kilowatts. But the charging industry has been responding to RFPs from the automakers to make sure we've got the technology ready to go. And so in the next few years, you're going to see that charging time decline. I will say that most people charge at home or work. 80% of charging is going to always be there. So fast charging and the gas station model won't necessarily be what you depend on. Most of your charging will be slower because you're going to park wherever you can and just charge during the day.
You've got time for one last question. Gentleman on my left.
Yeah.
Hello.
Thank you. Joe Peters, Peters Energy Solutions. I want to build on what John said about, well, it's just a matter of the timing. We can easily do this with a lot of the existing infrastructure. But how receptive will the consumers be to a demand to adjust the timing of when they charge their vehicles or use other appliances and that sort of thing? And by what methods will we make that happen, and will they actually respond in the way that the engineers hope?
I can start with that.
Yeah.
I think there's 2 ways to handle it, and this is something that the industry is debating widely right now, and often, but sometimes at conflict with some solar rates that might be created. So time of use makes a lot of sense for residential, single family or multifamily, where you know when you're going to plug in, and encouraging a driver to wait to charge later or set their car or their charging station to start charging when it's accurate with that rate makes a lot of sense. But it's a lot harder in workplace or a fast charger to plan out when you're going to charge. In those cases, we think managed charging makes more sense. So having a rate directed to the site host or the owner of that station so that they can ramp up and down the amount of power flowing from the station to the car. So instead of going at 100% capacity, maybe you're charging at 50%. It'll take a little bit longer, but when you're at a workplace, you just want to make sure you're fully charged when you need to leave. Throughout all this, it's really important to communicate to the driver. We don't want to disincentivize people from getting EVs now. We need more load to be able to have that managing opportunity in the future for the grid. So we think it's really important to communicate with both the site host and the driver.
We'll wrap this up
briefly.
short.
my phone probably has more computing power than the AESO had in the 1980s. I imagine at some point in time where there's going to be some capacity where we state our preferences to whatever home AI or what have you, and it then sorts out what you need to do. Like probably on the sort of 5 to 10 year scale, that's probably coming.
Which we already are doing with San Diego Gas and Electric has a rate where you actually select the time you want to charge a day ahead, and it's based on the amount of solar on the grid. It's their vehicle grid integration rate. So we developed an app that actually allows someone to check the times, mark it, and then schedule their charging associated.
At some point, we're just going to let the AI take over, right? I mean, just, okay, this is kind of what I want. Just go and deal with it and make it happen, right? So, okay, well, I think that's going to wrap it then. Unfortunately, we don't have time for more questions, but I want to thank my panelists. If everybody could give us a little show of appreciation. Thanks very much.
Thanks, James. Thank you, everyone. That was terrific.
Okay.
What kind of phone do you have, by the way? Just kidding. That's great. There we go.